Joyent is a sponsor of our ebook series on Docker and the container ecosystem. Learn more about Joyent's perspectives on these timely and important topics in our latest ebook about application architectures and microservices. It's available for download at thenewstack.io. Hey, it's Alex Williams of the New Stack here with Bryan Cantrill of Joyent. Bryan, good to have you here today.
Thanks for having me.
You bet. And so the topic for the day is microservices, and the historian that you are, I thought we might get your perspective on the context of microservices as we're discussing it today in this world of containers.
Any actual historian who's listening, I think it is probably just dropped dead of a stroke. I think the idea of me actually being promoted to historian would give actual historians an aneurysm. Well, I mean, so of course, there, as you know, I need no prompting to go into history, but I think in this case, as in many, the history is relevant, and I think that microservices as we know them today are actually a historical trend going on for quite some number of years, and it really goes back to kind of the dawn of the internet age and scale-out architectures, which, remember, we used to call these service-oriented architectures. And you kind of had these three-tier architectures and went by a bunch of different names, model view controller and so on. But we stratified our architectures into these three tiers, which was great, and it was good, and we built a lot of scale-out internet infrastructure that way. And I think what happened is that, over the course of the mid-2000s, we began to actually get web technologies seeping into the back end. I mean, it started with AJAX. I feel like AJAX, as long as you promoted me to historian, I think, can we go on an Antiques Roadshow with AJAX? We never say AJAX anymore.
Let's go on an Antiques Roadshow with AJAX. I like that.
Yeah, well, I feel like if you ask a millennial on the street, they might not know what AJAX is. So AJAX was a briefly lived, in retrospect, acronym for asynchronous JavaScript and XML. Totally terrible acronym. One of the letters is a conjunction, and another one's an abbreviation, so it probably should be a capital crime for acronyms. But AJAX started in, what would you say, like 2005, right? 2006. Mm-hmm. And it started with this kind of realization that, hey, wait a minute, this language on the browser is actually a real language out there, JavaScript, and we can actually go build an app that straddles the browser and the server side. And I think, what Gmail must have been 2004, 2005, something like that. Maps was early 2005, something like that. But kind of in the mid-2000s, we saw this explosion of really interesting apps that straddled this boundary, and a bunch of us, and I assume that I was among many at the time of that kind of generation that had grown up with JavaScript being really only used to set the blink tag or whatever, right, to animate a web page, and all of a sudden, to learn that JavaScript was actually a real programming language. It was like this learning about this forbidden attraction, and then to learn that you actually liked JavaScript or even loved it. I mean, it felt filthy at the time, and it felt like one of these things you had to keep to yourself. But then a bunch of people made that same realization, and a bunch of us started using JavaScript because that's what you needed to do to make this kind of new breed of applications. And we were using REST, right? You had the whole kind of REST, another terrible acronym, representational state transfer. But the idea of building these HTTP-facing APIs, and so you kind of had this cultural experience with that from the mid-2000s and kind of the latter half of that first decade. And I think a bunch of people had this kind of a similar realization that maybe 5 years after that, which is, actually JSON over HTTP is actually kind of nice for building an app that's internet-facing. Why am I not doing my apps that are strictly server-facing in the same way? Why am I suffering through this kind of this big monolith sitting in my controller tier? Why not break that up into smaller things that speak these smaller APIs? And that emphasis towards small systems, that kind of the reaction against large monoliths and towards small systems is, of course, a reaction that's as old as time, right? That is the small systems kind of revolution. That's the Unix thinking. That's the Unix philosophy, that you build instead of building these kind of massive things that are heavily specified, you build much smaller things that do one task, one understandable task, and they do it well. And the Unix philosophy is a really powerful revolution in systems thinking, largely because I think it allows us to get below Dunbar's number in the way we organize these systems. And you can really focus on just the thing that you can wrap your brain around a smaller number of services, and then kind of compose these things into larger functionality. And I think a bunch of forward-looking architects, software engineers were building systems this way circa the first half of the second decade of the 21st century, so 2010 and 2015. People were building things this way, and I'm not even sure when I know Martin Fowler coined the term microservices. I'm not even sure when it was coined, but I feel that once it was coined, it was coming after a bunch of people had already started to do this. I know that, speaking of Joyent, we had a monolith that we broke into microservices without calling them microservices. I mean, we only realized after the fact that this was a trend that others were discovering as well. So in many ways, the idea of microservices is much older than the actual notion of microservices. The name microservices is, if anything, is a lagging indicator, and many of us have been building systems this way for quite some time. But now that we're kind of given a name to it, it's been able to spread much beyond that initial use case.
So the container story is an old one too. I mean, you're the historian of record here for this show about containers as well. Back in those early days of container technologies, were there kind of was there any kind of thought process about how applications could be developed in different kinds of ways within those earlier versions of container technology?
Yeah, boy, I wish. And this is where I would love to romanticize history, but staying true to my role as historian, I must be honest and say that, there really wasn't. I mean, I think that when we initially did jails and FreeBSD in the late 90s, early 2000s, and zones at Sun back in the day, I think that the thinking was more towards application consolidation. I don't think anyone thought that containers would become pervasive enough that they would intersect with an idea of how we make applications themselves smaller. Indeed, if anything, zones were designed to reflect the fact that applications themselves had become morbidly obese, had actually grown out of a single binary, and had, now you had a single app that had an app server and a database server and a web server that were all part of it. Each of those things wanted to own the whole system, and the only way we could meaningfully get multiples of those apps onto one system was to give them a virtualized view of having the entire system. So that was actually the genesis of that. It was actually to make morbidly obese apps be able to run on really big computers. And the irony is now that where containers have really found their fit are really around much smaller applications, microservices, and running on effectively smaller machines, and not running on these kind of big vertically scaled 747 pallet-sized boxes, but these kind of these 2U sweet spot boxes that comprise the cloud. Now, that said, I think we at Joyent, when we were going to implement, I do think that our own use of containers, we've used containers around here since 2006. I think our own use of containers very much informed the breaking up of our own monolith. We built software that controls the cloud that was very monolithic. We deliberately broke that up into a smaller series of services, and without question, we knew we were going to give each one of those services its own container. That was really core to the way we architected that app. And that re-architecture took place circa 2011, 2012, and was very much container-centric. So for us, containers and microservices very much went hand in hand. We just happened to have been, I think, ahead of the curve a bit. And I think now what people are discovering is like, boy, if I want to go to deploy a bunch of microservices, now in many ways, the morbid obesity is at the other way of the stack. It used to be that the app was morbidly obese, And so we needed a thin infrastructure tier to accommodate it. And now the app itself has gone on a crash diet, has become much leaner in terms of a microservice, and now it's sitting on top of the substrate, the VM, this vestigial substrate that really itself is much heavier weight than it actually needs to be. And a container is a much lighter weight abstraction. So finally, we've got kind of the right fit between the abstraction, namely microservices, the upstack abstraction, and the downstack abstraction, namely the container, are really good fits for one another. And, you know, in terms of the broader ecosystem, the broader world, I'm not sure which is coming first and which is coming second. I think that these are two trends that are mutually reinforcing one another. I mean, they're certainly related and they feed off one another.
So why don't you, so let's do an exercise, and perhaps maybe you can now become the futurist and argue each side about which comes first and which comes second, and then maybe we could think about the inverse as well. How about that?
Yeah. Now, that's fine. Now, I should tell you, I'm comfortable being promoted to historian, but I think I've got a much better track record as a historian than futurist. I just want to, I want to caution that I have been wrong way too many times about predicting the future. Although, actually, that said, so one of the things we used to do back in the days, we used to gather after every January 1st, and this is back at Sun in the kernel group, and make a series of predictions. And we would make predictions 1, 3, and 6-year predictions for both Sun and for the industry. And we kept this for almost a decade. And it's very interesting to go back on those and see when we were right and when we were wrong. And basically, we were wrong most of the time. So I just want to qualify that by saying we were wrong most of the time. And then I will add as a final qualifier that and I couldn't believe this myself when I went back and looked at it, that in 2003, I made a 3-year prediction that Apple would develop a new device called the iPhone that would be a combined cell phone, digital camera, and MP3 player. So I feel that I was very much ahead of the curve on that one prediction and wrong on most other things. That's right. Unfortunately, I'm pretty sure I also thought it was a stupid idea. I was predicting it, but I thought it was moronic and it would go nowhere. So, of course, that was also wrong. So anyway, sorry. Yeah, so to play I have now have my very shaky futurist hat on. What would you like to know about the future?
Well, so now that you have your futurist hat on, you're talking about what comes first and what comes second. And so I'm curious, you know, you're not sure which one comes first and which comes second. I'm trying to think of the context for what you're talking about. We were talking about the substrate and the containers technologies.
Yep. In terms of which trend is going to be, I do think that in the end, it has to be that microservices or the way and what the developer actually needs has to be the kind of the leading trend. To me, the mega trend, if you want my mega trend here, as long as instead of being futurist, I feel that we may be seeing a very big shift in the way that capital is allocated. And historically, capital was allocated to our compute vendors, right? Mm-hmm. In the beginning, we paid all money to IBM. And, you know, over time, there have been a series of revolutions whereby through these disrupting innovations, you've had, ultimately, you kind of shatter the vendor over and over and over again. And we've seen now many iterations of that. I personally wonder if in this we're seeing a kind of an almost final shattering of the old guard IT. I mean, you know, Vinod Khosla at Structure last week said that, you know, Dell, EMC, and IBM haven't innovated at all in the last 30 years. And I do actually wonder, I don't necessarily concur with that, but I do actually wonder if we're seeing a kind of final shattering of the traditional way of thinking, and the way capital is going to be allocated is fundamentally different. And I think personally that you're going to have, as software becomes the new literacy, I think you're going to have more people developing software. I think more people developing software as competitive advantage. I view this as kind of the Uberization of mainstream corporate thinking, where I think more and more companies are going to have, and what makes Uber interesting is not just the company itself, but the fact that it is using software to disrupt a very old industry. I mean, the taxi industry survived any number of technological revolutions intact. And yet it is this final software revolution that is effectively destroying it permanently.
You know, what's interesting about that is that if you think about it, if containers are a symbol of, you know, the changes in, you know, in how people think about technology stacks, Uber is in many respects a symbol of how people think about these changes in business. And
that's exactly right. And I think that it is in many ways, that's the bigger trend. I think that the kind of the Uberization, if you will, of mainstream commerce, of kind of mainstream corporate thinking, is requiring people to think about how they move faster as a business. And that almost always means software development. I need to have greater agility in my infrastructure. I need my infrastructure to move faster. I need my developers to move faster. I need to be developing more software. I didn't think software was a core competency for me, but oh my God, I'm waking up and yes, it is, because, you know, between the, you know, Uber or an Uber-like competitor and or Amazon, I think that you are very hard pressed to find a company that can say with confidence that there is no analog in their industry. And even if you're in very traditional industries, you're seeing this effect. So I think that is requiring people to think, God, I got to move a lot faster. I need to develop software. I need to take software development seriously and move faster. The way to do that, I think that people are realizing, is like, actually microservices allow me to actually think about the problem in terms of these smaller pieces. I can then, you know, because everyone is going to have this kind of build buy or build download, as the case may be, kind of decision across the company of like, for each of these components, do I get a kind of an open source component? Do I buy a service for this? Do I build it myself? And a microservices-based architecture allows people to make those decisions at a finer grain, I think, and then allows people to really focus on the software that they need to develop to compete. And I think that is ultimately, or might be, I should say, I should posit that this is, you know, a possibility, or the kind of the way I see it, but I think that might be the big driver here. And if that's the big driver, then I think microservices are a symptom of that, and I think containers are a symptom of that. So I think that is ultimately, it is developer agility. It is a desire for business agility that is driving developer agility, that is driving microservices, that is driving containers.
What does that say about application development as it is now that's not container-based?
Well, I think that's going to change a lot. I think it has to. I mean, I think that you're going to see, you know, that folks, and it's not even necessarily whether you're container-based or not, it's more that being kind of container-centric reflects this kind of new thinking, that if you're container-centric, you're probably also thinking in terms of microservices, you're thinking in terms of a distributed system, you are kind of thinking in a modern fashion. And I think that this is going to have to become the new normal. So I think that we are going to see, again, we're seeing this massive structural change where a lot of the extant way we have kind of built and delivered software has to change. I mean, it does not make sense in this new world where entities need to move faster and develop faster. So I think, you know, it really, folks actually need to be rethinking and getting ahead of it and understanding that, you know, they need to understand, how do I make my customers faster? That it is agility that is the driver. And I do think that wherever you are in the IT spectrum, you need to be able to answer that question convincingly. And if you can't answer that question convincingly, you might be in dinosaur danger, because you may be, and, you know, I saw this certainly with the disruption of x86, the disruption of Spark by x86, the way that kind of economic disruption happens, you don't even feel it to a certain degree because you're not in the room. If you don't make developers faster, it's not like someone is going to try to drag you along. They just won't include you. And you'll wake up one morning and your revenue will be dropping and you won't know why. And there'll be actually no way to recover. So I think it is incumbent upon everybody, whether one is in kind of the traditional vendor ecosystem or certainly, anyone who's building software, in infrastructure software in particular, needs to really be focused on how do I make the users of this technology move faster? How do I enable that kind of speed?
So how can a company use Uber as a symbol if they're not taking a container-centric approach? Is it possible to have that same speed and agility?
I don't know how you get there with a monolith. Put it that way.
Okay.
If you in the traditional architecture of a slowly revving monolith, I don't understand how you get there. And part of the way I don't understand how you get there is because you kind of have the software equivalent of what we saw in hardware a generation ago, where when eBay first built out eBay, they started with a very small machine, and that grew to a very big machine. And that very big machine ran all of eBay. On the one hand, it was amazing that that machine was able to scale, and I say that machine because it was one machine, that machine was able to scale to run all of eBay. On the other hand, it was not wise. And everyone was afraid to touch that box. They didn't want to upgrade it. They didn't want to patch it. And when that box had died actually on a known bug and then hit a second known bug where it obliterated itself, eBay was dark for 22 hours. I'm not sure if you remember this. This was actually in the late 90s. You can still Google the eBay outage, made CNN. It was a very big deal. And what people realized from that is that monolithic hardware was the wrong answer. And they went to this scale-out hardware to survive those kind of disasters. But ironically, we stuck with monolithic software for a little bit longer. And I think in this kind of modern era, that monolithic software doesn't make sense. You need scale-out software that is going to have to be, I think, with smaller, better defined services. If the term microservices makes you throw up your mouth, and it does for some people, for some legitimate reasons, I think that the proponents of microservices can become somewhat breathless and a little bit ridiculous about not accurately portraying some of the challenges of microservices. It's not obviously. It's not that microservices are a panacea. It's simply that they are better than the alternative, which is really not tenable. It is not tenable to have a monolith that you are afraid to upgrade, because then you can't move. Then you want to change something and you can't. Or we made the change and we're waiting for it to roll out, and in six months from now it should be running in production. Well, not good enough, because your competitor, your Uberized competitor, has already rolled out that feature and is moving aggressively towards you. So I think that the monolith doesn't work when you want to move faster, and you need to move to a model where things are broken up. Once you're at that model where things are broken up and you've got these kind of scale out services and so on, then you got to ask yourself the question of, okay, so the infrastructure that's going to house that, what is that, and how do I get infrastructure that matches the agility of those services? And that's where we would say VMs don't make sense, where now you've got this heavyweight infrastructural abstraction that you're putting these little microservices on. This is where you really want to move to a container-based infrastructure. And then, and this is where you get the Joyent's book in particular, our belief is that you need to move beyond simply running in containers. You need to move all the way to container-native infrastructure, where it is the container that's running on the bare metal. You're provisioning the container. So the microservice runs in the container, runs in the bare metal, no VM, no guest operating system. That's the world that we think best reflects the agility that everyone needs to get to.
With that, that philosophy in mind, that if we talked about the accuracy of how to portray microservices, and containers by default, are distributed, correct? So you can have this capability. It's almost like this built-in capability with containers to start getting ahead of the game a little bit with your efforts to build out a microservices environment. And so if that's true, then what are some of the the realities that you still need to be thinking about that do accurately reflect the challenges that do come with building out microservices environments?
Yeah, well, a couple of things. One is that, first of all, microservices are a distributed system.
Right.
And, there's a little bit of you say distributed system, and people rightly feel a combination of both exhilaration and terror. In that a distributed system, everyone knows that distributed system is hard. But microservices sound easy, and yet this is a preschool versus daycare kind of distinction. These are two names for effectively the same thing. Mm-hmm. Microservices are virtually always going to imply a distributed system. A distributed system, it implies a bunch of things. It implies that you need to be very upfront about your state and about CAP trade-offs. CAP is the CAP theorem, Brewer's theorem, that says of consistency, availability, and partition tolerance, you can only pick two of those. And those kind of coming from the old world will say, oh, if I can only pick two of consistency, availability, and partition tolerance, I choose consistency and availability, and I just won't be tolerant to partitions. And as it turns out, you can't do that. There's a little bit of an asterisk on CAP. It's like, it's consistency, availability, or partition tolerance. Pick two, and you have to pick partition tolerance. So it is really picking consistency or availability. So when you have a network partition, which doesn't always happen, by the way, because a cable's been cut. Like that's actually would be the most unusual case for a network partition. Most often, a network partition happens because you sent a packet to somebody who's not responding. And often they're not responding because they're having their own bad day. They are busy doing work. They've got a TCP stack that has already packed full with packets or what have you. So they are not responding for reasons that have got nothing to do with the physical quality of the network, everything to do with it, just either a software bug or load or what have you. When that guy doesn't respond, when your cohort, your peer doesn't respond, do you choose to be consistent or do you choose to be available? That is a very key distinction. You don't need to make one decision across your infrastructure, but you do need to be very deliberate about the way you decide that. So that's kind of, you got all of your CAP trade-offs, and that requires someone, really thinking carefully about this stuff to figure out. More generally, how do you deal with state? If you don't think about this really constructively and deliberately, you will sprout state, which is very bad. One of the things that I always recommend to people is you want to have a very small number of services that actually store a canonical state. That for most people, you want to have a kind of a key value service that is your one key value service that you're going to use across all of your applications.
So what do you mean by sprouting state?
Well, that if you deprive developers of state, they will find ways to keep it. So, I kind of joke with people that Redis is often the gateway drug for this. So Redis is an in-memory database that can totally safely be used as a transient store. So that is, say, something that is not considered authoritative. But Redis can also be made persistent. And generally, when people are using Redis and making it persistent, it's a red flag that they are actually storing state. That they may not think of it as authoritative, but it's actually authoritative. And and you can think of this can happen in any number of ways. But you've gone to update something that a service is tracking, and that service ends up storing it locally before it makes a request that stores it somewhere else that's considered authoritative or canonical, or maybe it doesn't even forward it on. Maybe it considers that storage to be canonical or authoritative, even though it might not be replicated or it might not be HA. It's sprouted the state, and you only discover it, when things go sideways, and when the state's gone, the machine's been nuked, what have you. So you want to be very careful about having state kind of accidentally squirt out the side of a microservice. You want to be very deliberate about where state is. And again, I always recommend have one service that is your key value service. Cloud providers have services that you can use. I always think that that's one of those things that you really need to own yourself. And it's like a database trade-off, right? It's like actually choosing, being very deliberate about your database, but this is at a different tier. And you're kind of making that decision. From that, many decisions will spring. But you don't want to not make that decision or think that, we'll just kind of defer that, because what will happen is where developers need state, need to represent state, they will simply add it to their microservice quietly, which you don't want. So that's another kind of pothole that folks need to be aware of. I think another one is you got to be aware of microservice sprawl. I mean, it's easy to have these microservices that are, and I think you don't want to be overly dogmatic about it. I can't remember if it was Netflix or Uber. One of them had, or perhaps it was someone else, if I remember correctly, had an MD5 service where you send it an object and it would give you an MD5 hash. And on the one hand, this seems like a very small bit of functionality to have in a service. It seems a little ridiculous. On the other hand, at least that's a very well-defined kind of a service that's not going to, it seems like that's something, an abstraction you commit to. It doesn't seem that that's going to grow a lot of nested interdependencies and so on. I think when people get in trouble is when they break apart two things that really want to be the same thing, and they end up having all these kind of back channels and side channels about the way these two things talk to one another without having kind of well-specified APIs. I mean, one of the things with microservices is it's very easy to be sloppy, like JavaScript itself. It's very easy to be sloppy with these JSON APIs, and you need to be rigorous. You want to have the best of all worlds, where on the one hand, you have some of the agility of having a JSON payload that describes your API. On the other hand, you don't want to be so loosey-goosey that you end up having a one change in one microservice that breaks a wholly different microservice because things have been schemaless and so on. So you need to be careful about how you actually specify those payloads. We use JSON schema for that. But that's still a kind of an emerging area for us. We're still trying to figure out, the right balance between rigor and agility, and that really is the balance that needs to be struck.
Yeah, that's something we hear a little bit more about, this issue of resiliency. Ruggedness, I hear, as a term to what you're talking about.
Yeah, and I think that the other kind of challenge with that is when you've got these complicated environments, how do you replicate that production environment for a developer so they can meaningfully, when you've got one of these services that's kind of tied in a knot with a bunch of things, how are you able to meaningfully kind of update that service? And you run the risk of having a monolith that you're just calling a microservice, where you've got a monolith that's actually spread across a number of microservices. So, to really accept microservices, you need to actually accept that they're going to be these hard interface boundaries, and you need to treat them as such. And that requires a level of discipline, and indeed it requires a level of inter-organizational cooperation that may be the most impossible thing of all. So I think that's definitely a challenge you're deploying microservice-based architectures.
So you guys had a post up. Tim Gross wrote it, and it looked at microservices stack in seconds, Node.js plus Docker plus NoSQL. It seems like we're seeing more of these blueprints emerge, right? For these microservices architectures. We're starting to see them pop up all over the place. So I'm curious on Joyent's perspective on those microservices architectures, and I think this is a good example of that. Perhaps you could take us through this example and why it makes sense to you guys.
Yeah, I mean, and this is an example that is, it's using a bunch of components that people are going to find familiar, especially those that have been using microservices. So, I mean, it's using Nginx, it's using Node.js, it's using kind of a custom Node.js component, it's using console, which we're big fans of. So it's using kind of a bunch of usual suspects. I think from our perspective, kind of a key ingredient here is Triton. Triton is our container native service, and our big belief is that Triton allows people to really simplify these architectures, because in Triton you provision a container, and a container has an IP address. You don't have this VM container distinction where you're provisioning VMs and then provisioning containers within those VMs. You can provision only containers, and when you provision only containers and never provision a VM, you're able to take this kind of cookbook for this microservice, and you are able to deploy it in seconds, because you don't need to wait for a VM to be provisioned. You don't need to rustle through the networking config and so on to get containers in two separate VMs to talk to one another, which is historically a giant pain in the butt, you're able to actually spin these things up really, really quickly because the container is the primitive. And it's kind of ironic because Docker Compose is something that we actually are we're fans of. I like Docker Compose. I think a lot of people actually like Docker Compose. The rub on Docker Compose is that it's overly simplified. It really can only point you to a single Docker engine. It can only point you to a single VM. In the Triton world, where the Docker host is the entire data center, Docker Compose is actually much more useful than people might have traditionally found it. It ends up being much more sophisticated, even though it actually is no more sophisticated.
How does it become more sophisticated?
Well, it becomes more sophisticated because the sophisticated bit has been pushed down stack. Instead of Docker Compose having to be aware of the fact that it's talking to n different engines, it's talking to a single Docker engine, which is in fact a Docker Remote API endpoint that's being implemented by Triton itself. That endpoint is then intelligently virtualizing the entire data center. So the smarts live in the endpoint, not Docker Compose, which allows Docker Compose to be naive yet have sophisticated operation. And, per Tim's example, allows you to spin up this entire stack in seconds from nothing, as opposed to everyone kind of assumes that you already have, these VMs kind of cooked and prepared. And that recipe really assumes that you're starting with really nada and going from a full, resilient, operable, operating service. And I think that, that is the big trend in front of all of us right now, or the big challenge in front of all of us is how do we up-level thinking from containers to services. Mm-hmm. And even though containers and microservices have really reinforced one another, the thinking around how we express a service is still surprisingly fragmented. And I think that has to consolidate to a certain degree. It has to be simpler to think of a service. We made it, with the Docker revolution, we made it really simple to think of a container, easy to think of a container. I don't think it's easy right now to compose multiple containers into a truly resilient modern service. Not yet, anyway. I think that microservices in seconds blueprint shows a way towards the future where we can begin to make this much simpler by using container native infrastructure to actually think in terms of our services and be able to hydrate multiple containers into a comprehensive, coherent service that we stand up very quickly in production.
It's interesting to think about Docker Compose in this context, because one of the things I'm hearing people talk about when they discuss microservices, they talk about contracts about software. So they talk about contracts about software, and they talk about a lot about that's a big role of the YAML file. Right? Basically, this is the contract. Here it is. This is how things should work here. And so when you talk about the sophistication of the Compose file of Docker Compose, it talks a lot about these new concepts about how do you treat these distributed environments, and how do you set the contracts for them.
Yeah, and I think that when you kind of have container native infrastructure, you're allowed to very easily translate the contract into the construct. And I think absent that, you've got all of this hair and kind of bureaucracy that you need to deal with getting from contract to construct, because you've got this vestigial abstraction in the middle of the VM that requires you to kind of retranslate everything and confuse everything, frankly. So I think that from our perspective anyway, container native infrastructure is a very important leap forward. And we think that, by the way, we might be ahead of the curve, but we think lots of other people are going to make this realization. This is not going to be the only container native game in town by any means.
So you've served as the historian, the futurist for our discussion here. How do you want to leave this discussion, Mr. Cantrill? As the historian, the futurist, or something else?
Well, maybe a combination. Maybe the future historian. Okay. I'm not sure about the historical futurist. I can give you both perspectives. I can give you both. You can decompose the future. How about that? That's right. So, let me give you, I'll do the historical futurist first and then future historian. So historical futurist is that I have personally believed for a long time that containers were the future of de novo infrastructure, that VMs did not make sense. What was interesting was that for many years, we Joyent were making this case, and it was kind of blank, in terms of the response, in part because we were constantly emphasizing the operational advantages, and we didn't really make the connection to the developer. And so the historical futurist was right about containers being the future of infrastructure, was very wrong about the timing, because I thought it would happen sooner than it did, because it didn't connect to the developer, and it didn't connect to that agility. Mm-hmm. So I do think that we have to view the success, the presence, and certainly the future of containers through that lens of empowering the developer. That's a very critical element to this trend. So that's the historical futurist. In terms of the future historian, and trying to project myself into the future, I think that at this point we can say with confidence that containers are the future of infrastructure. I think that we don't have to guess about when it's going to happen because it's happening now. I think that, to me, the only question from an infrastructural perspective is how long does it take for other people to make the same, not just realization, but actually realize in not just the kind of the idea sense, but in the actual manifestation sense, realize the container native infrastructure and actually achieve container native infrastructure. I think that, again, this VM abstraction is vestigial, and I think we will see the logical conclusion of the container revolution. And I think that projecting into the future, I think that it is an all open source world out there, which is going to make things really interesting. I think that we are going to begin to codify the service much better and get beyond just the kind of the application and think about how an application is comprised of many different services beyond the container. I think that we are going to have some consolidation of abstraction. I think right now it's pretty chaotic right now. One of the questions that I was asking folks at KubeCon was if we were at or near peak confusion in the container space. And pretty much the consensus was that we are not yet at peak confusion. Some people said that confusion was accelerating, which is actually terrifying. I think that we're going to see confusion crest here pretty quickly. I think we're going to see some consolidation of abstraction. I don't think it's going to be winner take all. I think there's going to be a couple, maybe a bunch of different stacks out there representing different ideas, different mutations. And I think that this is really going to be about enabling many more people to develop and deploy software. I think that at the end of the day, that is what this is about. That, Andreessen said famously years ago that software is eating the world. And I think that we right now are cleansing the palate, if you will, for software to devour the world. And I think that I think the world 20 and 30 years from now, I think we are going to see many, many, many more people developing software, many more people having to think operationally, and I would like to believe that we will have such mature tooling and abstractions that people will be able to deploy these systems into production and go from ideation to production very quickly and without having to understand many of the details at depth because they're deploying on container native, service-centric, microservice-centric infrastructure.
Which speaks again, Ken, of the discussion about Uber and the business in the business drivers that are playing out. We see kind of in parallel with container technologies, which both in both examples speak to the economic shift, that is seen throughout the software economy, so to speak. I was talking with someone the other day who said, at one point in time, if you were the CIO, if you'd go to procurement and you'd order a server, and it might take 90 days to get that server. So instead of ordering one server, you'd order 10. So you're always over capacity in some respects, right? So But now what we see is the shift the other way, where you don't need to buy 10 servers anymore, right? You don't need to even buy one. You can have someone else run those servers. So the economics have changed entirely.
Yeah, and we think that they're going to change again when you're going to look back on, boy, it used to be that we would spin up 10 VMs and keep them there like pets.
Right.
And now when we got something new to deploy into production, we just click deploy and it is deployed. And I mean, I think that's going to be the next kind of step function. And again, it's going to really allow many more people to develop software. I mean, I think that, one of the interesting trends that we're seeing is, you go to universities now, the biggest course on campus at many different campuses is that intro computer science course. So we are achieving software literacy, and what that's going to mean is many more folks who are going to think computationally, and that's going to have, I think, a real consequence a positive consequence for the way we think of really mainline activity is now going to be enabled by software. So Andreessen, as he has been many times before, I think was absolutely right that software is leading the world.
Well, thank you very much for your time, Bryan. It's been a great discussion as always. And so maybe the next time we'll have more discussions about you as the historian or the futurist. Maybe we'll have to buy different caps for you or something like that.
Yeah, we love to buy different caps, and we could definitely call me. I'm more than happy. The future me, I know, will have no problem throwing the present me under the bus and explaining why I didn't understand the future at all. I feel much more confident as historian than futurist. So we'll have to come back and look at my predictions and see how wrong I am. Because I'm sure, as I've often learned about myself, I'm often right on trajectory, but really wrong in the specifics. So we'll have to laugh about that at some point.
All right. Well, thanks, Bryan, and we'll talk to you soon.
Cool. Thanks, Alex. Take care.
Okay. Bye-bye.